Hello everybody, welcome back. Mr. Crofton here, bringing you some more awesome geometric concepts that we're going to practice and work on a little bit today. Today we're specifically working on properties of quadrilaterals. This is labeled part 1, because guess what? There's a part 2. Remember, as always, make sure you're writing down these problems along with me. It's 6 problems we're going to go through today. They're pretty quick, so just make sure you write them down, because hey, you're going to get the most out of it that way, and that's what I want to see tomorrow when you bring it in. So, without further ado, let's check out. We've got our quadrilateral family tree. So this kind of shows us the breakdown of where each shape kind of goes. And the thing to keep in mind, the most basic thing, every quadrilateral, the angles all add to 360. Okay, so that's kind of one thing that is passed down. Then it's passed down over here to the kite. It's passed down over here to the parallelogram, and then the parallelogram takes all of its properties and passes it down also to the rhombus. These are the 3 shapes we're looking at today, and that's why I'm revealing those 3. You might be able to guess what's behind the yellow and blue box, but we're not worrying about those right now. So, without further ado, parallelograms are our first one here. I'm going to kind of fly through these. Now, really, less of a property and more of how we identify it. A parallelogram has opposite sides that are parallel and congruent. Also, we've got opposite angles that are congruent. Is a good thing to know. Consecutive angles means the angles next to each other are supplementary. So looking really quick at that here, okay, opposite sides are parallel and congruent. Opposite angles are congruent. And consecutive angles are supplementary, meaning if this was, let's say 70 degrees, this is going to be 110 right here because they're consecutive, they're next to each other. The last part we have here then is the diagonals. They bisect each other, means they cut each other right in half. All right, let's check it out now, try to solve a problem. So remember, draw a quick sketch of this. Doesn't have to be anything too fancy, but draw a quick sketch and we can get going on it. Now, flying through my properties that I just revealed there, the second one said opposite angles are congruent. Well, guess what? This angle and this angle are opposite, so they're congruent. Boom. 65 degrees for Z, right off the bat. Nice. Third property said consecutive angles are supplementary. Well, this angle here and this angle here are what we call consecutive. They're next to each other. So that means they add to 180. So y is 115 degrees. Awesome. 2 down. That was pretty quick, painless. And lastly, well, the first property that we looked at is that opposite sides are parallel and congruent. And I've got them marked as parallel already, but hey, I can also mark them as congruent. Therefore, 2x plus 3 is equal to 4x minus 9. And then it takes me back to my good old Algebra 1 days. I want to get x by itself and solve for it. So subtract 2x here. I've got 3. After these cancel out, 3 equals 2x minus 9. I add the 9 over, and I'm left with 2x equals 12. When I divide both of those by 2, I'm left with x equals 6. Boom. Done. One problem down. Very good. Let's check out one more parallelogram. So get a quick sketch of this. You might notice right away, oh boy, looks like a lot more going on. Don't worry, okay? Break it down, little piece by little piece. Let's do green. So now the first thing that jumps out to me is my fourth property that I just revealed on the previous slide, 2 slides ago. The diagonals bisect each other, meaning this and this are equal. This and this, they're equal. Okay? Well, that tells me right off the bat, okay, y is 10. Notice there's no units given to me here, so I'm not going to expect units of you. You could write 10 units if you want, but we're all good. Okay, keep moving through now. A lot of markings going on here. So to try to make it a little clearer for you, I'll get rid of these. How about that? All right. Now, one thing that might jump out to you, parallel lines. This is parallel to this. So I can make kind of like a letter Z here, what I call the armpit of the Z. The armpits of the Z, those are congruent to each other, and one of those letters happens to be Z. and their alternate interior, so Z is 49 degrees. Awesome. All right, now I gotta find X, but I'm looking at it, I'm like, oh boy, I don't really know how to do this. But if I look at the other side here, this is a 23-degree angle, and it's kind of left on its own. I haven't done anything with it, so I gotta think something's gotta bring in. Boom. How about this? We've got another Z, so I've got, again, alternate interior angles. 23 degrees here. I already know this angle's 49, and that's X, so I want to take them both away from 180. Right? Because the triangle there, this triangle up at the top, has to add to 180, right? So I'm using a bunch of geometric tools here to try to figure it out. And let's see, if I subtract down, I should get boom, 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 boom. 108? Did I do that right? Looks right to me. So 108 degrees. So I use a couple things there. Alternate interior angles, the diagonals bisecting, and the triangle angle sum theorem. Nice. Let's move on to the next. Properties of a kite now. Let's see what they are. First, how we identify two pairs of adjacent congruent sides. Second, there's a lot going on here, but one diagonal bisects the other. It also bisects opposite angles. Next, diagonals are perpendicular. Okay, that's good. That's easier. And last one, non-vertex angles are congruent. That means if this is my kite, these two are my non-vertex angles there. They're congruent. All right, let's use it. Giving the kite it right. All right, right away, I'm going with what I just figured out, right? Non-vertex angles are congruent. X is 98 degrees. It's kind of funny. Anyways, quadrilateral adds to 360 then, so to figure out why, I want to, let's add 98 plus 98 plus 40. You know what? I'm going to admit I'm human and say 98 plus 98 plus 40 gets me 236. Awesome. Let's go back here. 236 degrees. So I need a total of 360. So I subtract 236 from there. I get 124. And boom, there's why. Cool, cool. All right, let's do another kite. All right, let's see. Now I got the diagonals in there, and I remembered that my third property, no, sorry. Yeah, third property of my kite says that the diagonals are perpendicular. So these are all right angles here. That means X is 90 degrees. That's a nice quick one to get. I just noticed I'm missing Z. What's that? Okay, that's my 90 degrees. Really, those are all 90 degrees. And then I notice, hey, I've got a right triangle, 90 degrees and 31 degrees. Subtract those from 180, and I should get 59 degrees for Y. Awesome. Keep it moving. Now let's get Z. I remember my one property says that this diagonal basically bisects the whole thing. It's my line of reflective symmetry, so I know everything on the left is the same as everything on the right. So, for example, this 19-degree angle is the same as this 19-degree angle here. Cool. I got 19, I got 90, and I got Z. Add those up and subtract from 180. Check it out in your calculator. Boop, boop, boop. It should be 61 degrees. Wrong. 71 degrees. See? Always good to check. And you know what? Look at that. 71 degrees. Always be careful. Everyone's possible to make mistakes, so double check those answers. Cool. Oh my gosh. My favorite moment of any day ever, basically. It's math geometry joke time. So, question is, why was the mathematician late for work? You ready for it? He took the wrong bus. He took the wrong bus. Like wrong bus, but wrong bus. Oh my gosh. That's just too good. That's just too good. All right. With that in mind, let's check out our rhombus. Properties of a rhombus are as follows. First thing, I know opposite sides are parallel. That is what a parallelogram is. So everything from a parallelogram also applies to a rhombus. What makes it more special, though, is that all sides are congruent. Also, diagonals are perpendicular. And lastly, the diagonals bisect the angles. Okay, so we got a couple more properties on top of the parallelogram. So let's see what we've got. All right, I'm given this as a rhombus here. So right away, look back at property number 3. Diagonals are perpendicular. I see diagonals in there. Label it with that box. It'll help you. And sometimes it'll even get you an answer right off the bat. Cool. Last property, the 4th one said diagonals bisect the angles. That means this diagonal is bisecting this angle right in half. That means x also has to be 35 degrees. Oh, baby, I'll take it. 2 quick answers. All right. And then I noticed something else going on right here. And really, with a rhombus, you're going to have 4 identical, congruent is a better word, right triangles in it. So they're all going to be the same, but I got to find out what z is. So this is 90. This is 35, as I already found it. I got to find z here. So add up, subtract from 180, and I should get 55 degrees. Very cool. Nice. That's dealing with the angles. Now, curveball time. What's happening here? FJKG is a rhombus. Okay. FK is 6. So that means this length right here, just really feel it out, right? That is 6. And I'm thinking about it like, oh, that's kind of hard to label. But when I look back, I see the first property of rhombus is everything from a parallelogram. So I look back again. The 4th property from a parallelogram is diagonals bisect each other. So if this red line here is 6, I know it's really 3 and 3. Okay, we're making progress. That's the first thing that's given. Second thing that's given is GK. Where's GK? GK is right here. Is 5. Okay, which really tells me all the sides are 5. But I'm not sure that I need that just yet. Well, I'll write it in. 5. 5. 5. Now what I'm looking for is, and we'll color it blue, JH. JH. Okay, I want that. But I didn't mark something that I did last time, so I'm going to do that again. Look, diagonals are perpendicular. Mark that right off the bat, and I realized pretty quickly this JH is really one side of a right triangle. Boom. This blue one here, I'm going to draw it separately just to give myself a little help. And not the best drawing, but either way it works. That's my 5. That's my right angle. This is x, and this is 3. If you're jumping out of your seat saying you already know what x is, then that's awesome. But if you're not, that's all well and good. We can all still figure it out. Right triangle, you got 2 sides, you got to find the third. Pythagorean theorem, got it written all over it. A squared plus b squared equals c squared. So my a is 3. My b is unknown. My c is 5. All right, square. 9 plus b squared equals 25. Oh, I can make it. Subtract 9 over, I get b squared equals 16. And with your calculator or with your awesome brain, square root of each of those gets me 4. And the reason you might have been jumping out of your seat is because 3, 4, 5 is a right triangle Pythagorean triple that we use all the time. We see it all the time, so that's a good thing to notice. But if you didn't notice it, it's all good. You get 4 either way. Whew. All right, that wraps it up for us here. Look back at our family tree. It's so beautiful. We're going to fill it out in part 2 of this video. But for right now, hey, we got 3 of our quadrilaterals down. We got 3 more to go. Good job. See you next time.